Okay, I assume you've read and worked the problem. I think it's another straightforward one, pretty clear as to what you need to do. So the question is whether you can do it. Okay. So let's go ahead and start with part A, write an equation for the line tangent at x equals 1. I think this is a pretty easy part of it. So at x equals 1, we already know the derivative is 8. And we need to find the point. So 1, and we need to find what 1 is. Well, they tell me in the problem f of 1 is 15. So y minus 15, 8x minus 1. Just add the 15 over to the other side. No need to clean up. Okay, so we've got that. Now it says use it to approximate y of 0.4, or f of 1.4. So plug in 1.4, I'll get 8 times 0.4 plus 15, which gives me 18.2 when I work that out. That's a 2. Part A was worth 2 points, one for the tangent line, one for the approximation. Part B, so let's find a midpoint, 2 equal lengths. Okay, so we're going from 1 to 1.4, so halfway through being 1.2, and we're using midpoint. So they are 0.2 wide. The middle between 1 and 1.2 be 10. And then the middle between 1.2 and 1.4 would be 13. So I end up getting 4.6 there. Okay. Now it says use that to approximate, so use that estimate, we just found that, to approximate f of 1.4. So we know the integral of 1 to 1.4 f prime of x dx by the fundamental theorem of calculus will give me f of 1.4 minus f of 1. And this is what we're trying to find. Now we just found this using a midpoint sum is 4.6. And once again, f of 1 they tell me is 15. So do a little addition there. F of 1.4 is 19.6. Part B will earn you 3 points. Wow, 1 for the midpoint, 1 for using the FTC, and then 1 for the actual answer. Okay, part C, we have an Euler's method. Okay, so we're starting with the point, 115. We'll need to find the slope. We'll need to find delta x, delta y. Now it says 2 equal step size to get 1.4. We're going from 1 to 1.4, 2 steps, so this needs to be 0.2 each time. Okay, let's plug in. At 1, my derivative is 8. So it's kind of a little different. We're not plugging into a differential equation. We have a table there. Multiply, I get 1.6. So x increased by 0.2. Y increased by 1.6. Okay, so at 1.2, my slope is 12. Multiply, I get 2.4. So x increased by 0.2. My y increased by 2.4. That'll give me 19. Boom. That was worth 2 points for your Euler's method. And part D is the one people mess up on, but it is a pretty straightforward Taylor polynomial. Okay, so we want f of 1, which is 15, plus, now remember it's f prime, let me actually write out my Taylor polynomial so you remember first. F of 1, we want f prime of 1 times x minus 1 to the 1, plus f double prime of 1 over 2 factorial, x minus 1 squared. Okay, let's go ahead and find out. It's 15. F prime is 8. F double prime, they tell me in the directions, is 20. Now 20 divided by 2 is 10. So there's my Taylor polynomial. It said of degree, second degree, so I have my second degree there. Now it says use it to approximate 1.4. So I need to plug in 1.4. So when I do that, I get 0.4. 10 times 0.4 squared. Do a little calculations off the side. You end up getting 19.8. And that part was only worth 2 points. 1 for your Taylor polynomial, 1 for your approximation.